Here we go. 10.6b is circumference and arc length. Can you tell me what circumference is in a circle? The distance around, right? It's the perimeter of a circle. So if this is my circle, if I have, this is my diameter, right? This is my radius. If I want to find the circumference of that circle, there's two formulas you could use. The one is pi times the diameter. The other one is 2 times pi times the radius. And if you think about that, it's the same formula. 2 times a radius is a diameter. So double a radius, you get a diameter. So it's pi d or it's 2 pi r. You pick which one you like to use and run with it, okay? If you're plugging pi in on your calculator, what number do you use for pi? Yes, it's approximately 3.14. Oops. But if you have a pi button on your calculator, you are welcome to use that every time because that's going to be the most exact answer. But 3.14 if you want, okay? Okay, so with circles, all circles are similar, meaning they're proportional, right? Because a radius is going to stay the same throughout the whole circle. So if all circles are similar, we're going to use those similar circles to find different things about our circles. So let's do this. This is like example 3 in the book. You have what are called concentric circles. Anyone know what concentric circles are? They're circles that share the same center. So, for instance, if I did this circle, and then I did that circle, and they both had this as their center, okay? Anyone watch NASCAR? Do you know what direction they always turn in NASCAR? Left. They always go left, right? So think about if this was a NASCAR track, not a track even. If this was the way the wheels of NASCAR were going, so here's the 2 wheels and the 2 wheels. If the car is driving around the track, which wheels are going further? The inside wheels or the outside wheels? The outside wheels, right? Because like they're track. If you're in the inner lanes, you're gonna. There you go. Yes, if you're running on the inner lanes, you have a shorter distance to run. Therefore, you get less worn out, right? So that's what we're gonna look at here. Is think NASCAR, think track. How much further does the one go than the other? Okay, and that's circumference. You're finding the circumference of one circle, the circumference of the other circle, and comparing, okay? So let's say the red circle has a radius of 7 feet, and the black circle has a radius of 10 feet. And I want to know how much farther, if we do one lap, for the outside wheels. Okay, so how much further are these outside wheels going to go than these inside wheels if we do one exact lap around that track? Okay? It's not 3. Because think about what that is. This distance, this circle, that's circumference, right? This circle, one lap around, is the circumference. So we have to find the circumference of both of those and then subtract. So if circumference is pi d, what would the diameter of the red circle be? The diameter, not the radius. Not 17. If the radius is 7, what's the whole distance across? 14, right? So the diameter of the red is 14. What would the diameter of the black one be? If this is 10, then the diameter is 20. Okay, so that means the circumference of the red circle is pi times diameter, so 14 pi feet. Okay, the black one, that means the circumference being pi times diameter would be 20 pi feet. Okay, so the outside tires go 20 pi feet, the inside tires go 14 pi feet. I want to know how much further did the outside ones go. So what you're going to do is you're just going to subtract them. You're going to say 20 pi minus 14 pi, and that will tell you how much further those outside wheels go. So can you subtract that, 20 minus 14?
Just do it.
You can, yeah, you can subtract them. You just have to attach the pi to your answer, right? So 20 pi minus 14 pi is 6 pi. Think of it like apples. 20 apples minus 14 apples is 6 apples, right? So 6 pi feet is how much further it goes. Now, do you know how far 6 pi feet is? It's kind of a weird number, right? So in this case, I would just plug it into your calculator, 6 times pi. And that comes out to approximately 18.8 feet farther. Let me look at your calculator. And you don't even have to put times in when you do pi. It just assumes multiplication. So you could literally just do 6 pi, enter, and that would give it to you. Okay, questions on that? Okay, so then that's dealing with the length of the full circumference of the circle. We're going to start talking a little bit about the length of just an arc, so a portion of it. But I first want you just to see a little comparison here. So let's say we have concentric circles again. That's terrible. It's still not great, but it'll work. Okay, so if they both have a center here, we're going to draw in 2 radii. Let's say this angle is 70 degrees. Okay? Forget about the black circle right now. What's the measure of this arc? If that central angle is 70, what is the arc? 70. They're the same, right? Okay, now forget about the red circle. Your central angle on the black circle is 70. What is the measure of this arc? Ignore the red one right now. This is your central angle, 70. It opens up to this arc. So that arc is 70. Okay? So here's where arcs can be a little bit tricky. Both of those arcs are 70 degrees. Are they the same length? Is this red one, if you measured it, how long it was, the same as this black one? Are they the same length? If you measure them? No, right? So in like inches, centimeters, they're different. In degrees, they're the same. Okay? In other words, they're the same fraction of the circle. So just keep that in mind. When they talk about arc length, they're talking about using circumference to find it. When they're talking about arc measure, they're saying how many degrees it is. Okay? So arc length, you're going to use circumference to find it. Arc measure, it's going to be degrees. Okay. Okay, so there is a formula for how we find the length of an arc. And it is this. You take the measure of the arc that you're using, we're going to call it AB. You divide that by 360 because it's a fraction of the circle, and a circle is 360 degrees, okay? So the measure of the arc over 360 times circumference, pi d. Okay, so that's the formula you're going to use. So we're going to just do a couple of those and find the length of the arc, and then we're done with this first lesson. All right, so let's say our circle looks like this. Okay, if they say find the length of arc CD. Okay, that means we're trying to figure out this length from C to D. Okay, so we're going to take this formula, and now AB is being replaced by CD. Okay, so we want the measure of that arc. How many degrees is this red arc? Excuse you. Can you tell me how many degrees that arc is? Are you with me back there, Cameron?
Yes, 90.
It would be 90, right? Because your angle is 90, so your arc is 90. Okay, so you're going to take this formula and just plug into it. 90 over what? 360 times pi, and then we just need the diameter. What's D right now? 12. Diameter is all the way across, right? So times 12. Now here's where you have to be a little bit careful. When you plug this in, you're not going to plug the pi in. You're going to plug this stuff in. So plug into your calculator for me. Do you have your calculator handy? Do you have your calculator, Hope? Hold on. Forgot to start recording again. Okay, this one. Yeah, I put them all in Canvas, and then you can go back and watch them.
Weird stuff during the lessons.
It's all good. Okay, so same formula, the measure of the arc over 360 times pi times diameter. What is the measure if we're going to find arc RS? Okay, so I want to know the length of arc RS. What's the measure of that arc? RS. 100, right? So you're going to do 100 over 360 times pi. What's D? Daniel, put it away. You guys are killing me today.
Sorry.
What's D? 18, right? If the radius is 9, then the diameter is 18. Okay, how do you plug that into your calculator? Plug it in, all three of you. Plug it in.
It's 9 divided by 180, right? Or 360.
100 divided by 360 times 18. What'd you get? 5. So then attach the pi, and it's feet. Okay, so that would be arc RS. What if they said instead, we want RTS? Which arc is that?
So cold.
RTS, that's this guy right here, right? The blue one. How many degrees is that arc?
More than 180.
It is more than 180. This is the only other piece to it, right? How big is that?
500.
100. So you're going to go 360 minus 100. That means that arc is 260. So for RTS, you're going to go 260 over 360 times pi times the diameter. So if you plug that one in, you would get 13 pi feet. Okay? Questions on that?